Hi guys, this is Piyush Madaan, faculty at Ask IITian. I have done my post-graduation from IIT Roorkee and I have been associated with Ask IITian for last 4 years. Today we will be studying work, energy and power. As you have seen that work, energy and power, these are the terms which we use frequently in the everyday language. We say that if we take an example, we say that a woman is carrying water from the well to her house is said to be working. That means if we say that she is carrying water from large distances, we say that she have a large stamina or more energy. So this is what exactly we associate these terms with these examples. And the third term which is there, that the power, we say that the power, okay, I'll not define because this is what we have to study. Okay, so in the coming part, we're going to see that what are the topics that we're going to cover in this PPT, and the next is that why is there a need for this work, energy and power. Now let's start with the work, energy and power. So the topics which we will going to cover for this PPT are first the introduction, where we will going to see that why there is a need to have the concept work, energy and power. The second thing which we will going to cover is the work. What exactly? Here we are going to define that what exactly is the work and what is the nature of the work. Now the third thing, after doing the work, what exactly the work is, we're going to apply this concept that how we can find it out work by the gravity and by the friction. This we will going to cover in the third part. Now in the next part we will going to cover that we will going to find it out that how we can find it out the work done by the variable force. That means where the force is actually the position dependent. This is we will going to cover in this topic. Now in the next topic we are going to see that the work done by the area under the force displacement graph. This we will going to cover in this topic. Now in the next part we are going to cover that what exactly is the work energy theorem, that how we can associate the work done with the energy. This we will going to cover in the work energy theorem. So next thing which we are going to cover is the conservative and the non-conservative forces, that what exactly are the conservative and what exactly are the non-conservative forces. This we are going to cover, and some details which we are going to cover in this part. Now the after work, the second term is the energy. So exactly, so this is the thing which we are going to cover in itself in the energy. So that what exactly is the energy and what are the types and what are the forms of energy, how we can deal with the motion with the energy. So this we will going to cover in the part energy. Now after that we are going to see that what exactly is the equilibrium and what exactly are the types of equilibrium. The types of equilibrium means, or we are going to categorize the equilibrium on the basis of the stability. This we are going to cover this in the types of equilibrium. After that we are going to see that what exactly is we are going to study the vertical circular motion, that when the particle move under the circular motion, that how we get the details of that using this concept work energy. Now the next which will be there, obviously after work, energy, and the last is the power, which we are going to cover in this. So after covering this power, we will be solving the IIT-JEE previous year questions which are based on this concept work, energy or power. So let's see the introduction. Now let's come to the introduction. That so as we can see this figure is visible to us, so that this is moving. Now what did I say, that what exactly is the need of this work, energy and power. Now so we are going to see that in the introduction itself. Now what is the role of this figure? This figure actually shows that the sphere is moving on the uniform slope. Uniform slope means this theta will remains the constant. Theta, the inclination making, this inclination making with the horizontal is the same at every point. This is what does this uniform slope means. Uniform slope. So now if it is given that the sphere is at this point B and has to go at this point A. Now if we are going to make the free body diagram of this sphere, so what we are going to get, let's say this is the sphere. So there will be mg which will be vertically downwards and normal which will be perpendicular to the surface on which it is moving. And so just consider that this is a frictionless surface. That means there is no friction over here. Now if we are going to resolve this thing, what we are going to get? We are going to get this as mg cos theta and this as mg sin theta. That means what exactly? We can apply the Newton's laws of motion, that the force normal is equals to mg cos theta and the force which is acting along the inclination is equals to mg sin theta. So therefore what we can say that acceleration is equals to g sin theta. So now I talked about the uniform slope. What did I say? That uniform slope means theta will remains the constant for the complete motion. That means this theta will be constant. Since g is constant, theta is constant, so a will be constant. So a is a constant. So what we can say now? We can say that since a is constant, so we can apply the equations of motion where v is equals to u plus at, s is equals to ut plus half at square, and v square minus u square is equals to 2as. So we can apply those equations to find it out the details of this motion. So therefore this is what is the main purpose. That means if something is being asked, so we can solve that thing using these kind of equation. Now if we'll see the next figure, that is this. If we'll come upon this, this is what exactly this is showing. This is showing the bunny slope. Bunny slope means that means non-uniform slope. That means at every position there will be some change in the acceleration. This is something like this. This is something like this. That means at every position angle with the horizontal will be different. So if angle at every position will be different, so what we can say that acceleration will be different, or let's say force will be different. Since the force are different at different position, now we cannot apply those equations of motion. Now we cannot apply those equations of motion that I have already told you, v is equals to u plus at and these equations. So now we cannot apply those equations. So therefore there is a concept, or therefore there is a need to introduce this concept, that is work, energy and power, to get the details of the motion. Now we can apply. Now let's see that we're going to see in this chapter that how exactly we're going to apply, or how exactly we can solve these kinds of complex situations or the difficult situations. So guys, we have learned that these many topics are there that is to be covered in this chapter, and also we have learned that what is the need of this chapter. Now let's move to next part.